फूडी पीला
फूडी कितने खाना है सबने
ये तो नहीं खाया
कुरकुरे
नहीं खाया हमको सबने खाया
बोल दिया
10 रुपए की कुरकुरी
ये बहुत है फटा हुआ है गोल गोल हां बबली अरे लाइटर है आपके पास लाइटर है एयर पे लाइटर है
अरे वो ऑन कर आप लगा देंगे
बस लास्ट में थोड़ा थोड़ा डालो ज्यादा
इधर थोड़ा डाल दो
नीचे गली में
इधर इधर भैया
क्या हो रहा है
तेरा मतलब
फूड का स्मेल आ रहा है
नहीं वो जैकेट में लगा भूख लगेगी सब बैठे होगा
बस बस
ये अच्छा है अपने अपने घर से लाया करो कॉफी लेके आते हैं थर्मस में भर के
कॉफी खरीदना है तो घर से लाता है
वो तो जो पुरानी कॉफी है
Okay, can everybody be silent?
एसी ऑन अरे यार
Can somebody remind me? Numericals? We already started doing numericals?
Yes.
Which numerical we did?
We did the first 5.
We did the first.
सेकंड तू आगे देखना इसको
देवना चैलेंज तो अरे मैं
Seventh of unit A, right? You come here. Seventh of unit A, right?
6 we did the last
Guys, can we settle down fast?
Can I go out and ask for the AP report?
Go get it. Go get it. Okay. Show me what did we do? Which question did we do? Sixth one of unit A.
unit A, yeah. Numerical.
So which goes like, read what was that?
Which one?
Sixth question, unit 2A. Okay, the question was electric heater of, that same question, right? Electric heater of power 3 kilowatt. That question, right?
Yeah, sir.
We have done it.
No, we have to do that.
We have to do it. Okay. So I'll be calling somebody to do it. Okay, being the first question, let me do it. Question 6. Just tell me if the data is correct. You missed the last lecture, is it? So electric heater of power
3 kilowatt
3 kilowatt.
and time but the duration is 10 hours.
And T is equal to 10 hours. Quickly, can you give me the formulas in this chapter? Let's write down the formulas. What are the formulas? Work done is equal to Fs cos theta, right? Or Fh cos theta. When do we use S cos theta and when do we use H cos theta? Horizontal motion S, vertical motion H.
For length you should use S and for height you should use
For
H.
power we have formula work upon time. These are the only two formulas, right? This becomes F into V also. This also is energy upon time. So these are the only two formulas we have. So power can be expressed as work upon time or force into velocity or energy upon time. Okay? So all the questions we are going to do will be solved by this. And sometimes force is if it is not given in Newton, if it is not given in Newton, only mass is given, then mass into gravity. That is force. Okay. Okay. Now, so how do we solve it? Power is 3 kilowatt. Stop discussing among yourself. Concentrate on board. Do in your notebook without chatting. Okay. Don't disturb them. No discussions allowed. Only try yourself. Okay, let's follow that rule. Only try yourself and ask me for any help. Don't discuss amongst yourself. Now P is equal to 3 kilowatt. P is this. What we have to find out? How much energy does it consume?
Kilowatt hour.
So E is equal to what? That is first you have to find out. Express your answer in kilowatt hour and joule. So you have to find out the energy consumed in kilowatt hour and joule. Solution.
E is equal to P into T.
So what is E? P into T. So E is equal to P into T. So first part is in kilowatt hour. So express it in kilowatt. 3 kilowatt into 10 hour. So this is 30 kilowatt hour. Okay. First answer you get it in kilowatt hour. What about joules? So E is equal to 30 kilowatt hour. But what is 1 kilowatt hour? So kilo is 1000. 1000 watt. So this is 1000 watt. R is 3600 second. Now watt and second is SI unit. So what second will become joule then? So this will be 1, 2, 3, 4, 5, 6. 3 into 36 into 10 raised to 6 joule. So how much is this? 6 is 18. 108 into 10 raised to 6 joule. But in standard notation, we write decimal after one figure, okay, one digit. So it is 1.08 into 10 raised to 2, which will add up to.
So why writing in decimals? We can only write.
This is the standard expression.
What is power rating?
What?
Power rating.
Power is what? Power rating is power.
Excuse me, sir.
Why are you asking?
It's written there.
Where in this question?
What's the eighth question?
We are discussing 6. So if you are doing 8, do it silently.
Excuse me, sir. Sir, is it alright if we will write 108 into 10 raised to 6 joule, or we need to convert it into standard?
So, sorry, repeat your question.
Do we need to convert it into standardized? Is it okay that if we don't convert?
Depends on the question.
So what is useful power?
So here what?
I'll explain. So for that you need to read and know efficiency. Which question you are doing? 8. Can you all do question 7, everybody? Is it simple?
Yeah. It's very simple.
Okay. So let's do 7. Everybody is not comfortable, looking comfortable, right? Are you all comfortable with question 7?
Yeah.
So do it. Can I go to question 8 directly then? Let's go to question 8. Since you are not asking me for 7. So there you go. A pump is used. What is given data in this? Given. Pump is used to lift 500 kg of water. So given mass is equal to 500 kg. Okay. In my book it is 500. 600 kg. Okay. Okay, give me data of your book. Then depth is 75 meters. Okay. What else is given? Time
10 seconds.
10 seconds.
And G is 10 meter per second.
G is 10 meter per second. G is
Sir,
equal to
10 Newton and
same
and 10 Newton kg.
per second square. It is same, right? F is equal to mg. So G is equal to F by m, Newton per kg, or G. Okay, from that one.
So for Newton kg and Newton both are same.
Newton per kg or meter per second square are same.
No, I'm asking for 7 because I'm doing something.
Yeah, let's do what I am doing. Okay, he is doing 8, you are doing 7. I think that's it. Do what I am doing, then we can discuss. Okay. Now, so right now let's do 8. If you have any doubt on 7, we'll come back. So what you have to find now? You have to find first the work done by pump. Work done by pump. So in the hurry of solving question, okay, don't compromise with the system. Like, write it appropriately. Work done by the pump is what? W is equal to what it should be? mgh. mg into h. Cos theta is 1 in this case because force is lifting up is mg and depth is h. So it is 600. G you have to take as 10. H is 75. How much is this?
It is 45, 450 horses.
6 5s are 30. 3, 6 7 are 42 plus 3 is 45.
45,
Then 0 0 0.
which is equal to 4.5 into 10 raised to 5 joules.
Correct. So this is 4.5 into 10 raised to 5 joules. So work done is everybody getting work done is this. So this is part A. The power at which the pump works. B. So now see, there is a formula, right? What is the formula of efficiency? Efficiency of a machine is given as output power, which is also called useful power or useful power, divided by input power. Okay, or power consumed. See, it's like this. When you eat, right? Say about 100 calories. Your output work is not 100 calories. Some of it you need for your body upkeep. So you can only do work, let's say 50 calories. 50 is required for your body's maintenance. Okay? So your consumption is always more than what you deliver. So that's how. What is the useful power of the pump? That is what is calculated here. Now, where is the power? Did we calculate the power?
We didn't do so. It is 45 kilowatts.
So power at which? So power. No. So that is C. Okay. We'll come back here. That's next.
Power is equal to
Power will calculate here. B. This is C.
power is equal to 45 kilowatts.
So what is power? Power is W by T. W is 45. 100 divided by time was 10 seconds. So this was, so what you will get? How much will you get? This is 45 kilowatt, right? Or 45,000. Right. This is the power. So this is the power, which is the power delivered. This is the useful power. This is the power delivered. So actually you have to spend more power to get this power delivered. You get it? This is the actual work done and this is the useful power. I mean, this is the work you are getting, right? Power in lifting the water. So this is the useful power or power used. Okay. Now actual power used
will be
this power. This is the power whose work got delivered. That is useful. But power used is you have to find out.
40%.
So efficiency, now this 40%. So it is 40 by 100. What is useful power? 45,000. Divided by power input you have to find out.
So this is the cost of for efficiency.
Eta. 88, eta. So this is input power input. What do you have to find out? Power input you have to find out. Okay, so power rating of the pump. So you have to use a pump of this rating, this input power. When the pump is running at this input. So what is input therefore? So therefore P input is equal to 45,000 divided by 4 into 10. So how much is this? So you can use 450 into 100 by 4, right? So this will be 25. So do smart calculation. 100 by 4 will be 25. So 25 into 45. 25 5 is 125. 25 4 is 100. 112. and this 20. This is
Sir, I have a question.
What is below 45,000?
power input. This is the formula, no? It's given in the book.
Input this.
It is input power.
नहीं वो दोबारा आप use का input.
Suffix है यार.
Sir, question. Sir, in that formula, I'm not able to understand what cos theta is used for.
Okay. This will be cleared in next chapter. Machines chapter में this formula is given in detail, so that then you will understand. Okay. Here they have just used it.
So I can't understand what's the significance of cos theta.
Cos theta here is water is lifted up.
Yeah.
So water has some mass. So F is in the upward direction. F
Yeah.
is equal to mg. And displacement that is in the vertical direction. So theta is 0. So whenever theta is 0, cos theta is 1. That's why we have not used it.
Theta is 0.
Yeah,
And
because
cos theta.
wherever force and displacement are in the same direction, there is force lifted, no water is lifted
So
up.
there cos theta would be 1, right?
Yes. So we don't mention cos theta wherever theta is 0. Because cos 0 is 1.
Sir, but so can we say that work is equal to force into
H. Whenever force and displacement are in the same direction.
yeah, so force into H instead of writing cos theta because cos theta is 1 itself.
Yes, it is. You can write where there is no angle. So in these cases you can write, but that is a general formula. Most general formula
And if
covering
there is
all
an
cases.
If there is a
And cos of that angle, that value you should know. So that is why I am writing is so that you have in your memory that the work will be different if the angle theta is say 60 degree, 30 degrees. Okay,
Yeah, so
or
it will
90 degrees,
replace
then it will be
theta.
0. Got it?
Yeah.
So that is how it is. So is this the answer? What is the answer? Huh? So this will be kilowatt में 112.5 kilowatt divided by 1000 kilowatt. All questions answered? Do you have any question? Power input. So power input is the actual power consumed, but you are not getting the full work. You are getting the work after the wastage because every device has some power dissipated as heat. When the motor is running, it is not only delivering the lift of water. Water gets heated, so that power is wasted. That is why efficiency is never 100%. Some of it is wasted. In the machines chapter, this concept will be cleared for you. Okay. So likewise, you have very simple questions now. Let's take question 12.
So 9,000.
Question 12 done? 10, 11 is straightforward. 9 you want me to do? अच्छा ठीक है चलो Question 9. Ox can apply a maximum force. What is the given data? Tell me. F is equal to how much in question 9? 1000 Newton. Okay. What else is given? It is taking part in a kart race, so it is on the horizontal surface. It is able to pull the cart at a constant speed of 30 meter per second. Okay? While making the calculate the power developed by us. So P is equal to F into V. P is force into velocity. That formula is there, right? So इसमें theta की कोई जरूरत नहीं है. Cart is running in the direction in which force is applied. So this is okay. So how much is this? 30. So 30,000 watt or 30 kilowatt. Power is 30 kilowatt. Okay.
So I'm not able to understand 40 by 100.
Efficiency given na in the question 40%. Efficiency is given is power rating of the pump. If its efficiency is 40%, so this input power is the power rating that you are calculating.
So why 100?
40% क्या होता है यार? 40 by 100.
Oh, अच्छा percent.
You are losing it, huh?
Let me see because there will be the same data.
40% is, everybody understand, right? 40 per 100%. Okay, so question 9, everybody okay?
You are writing a question.
Shall we do
No.
So 10.
अरे
10th हो रहा? 10th में क्या है भाई? Given क्या है 10th में? I'll just tell you the formula, okay? Steps you do. Given F क्या दिया होगा? Power दिया होगा. Given P is equal to 40 kilowatt. B is equal to F is equal to 20,000 Newton. 20,000 Newton. Correct? यही है ना? Power is this. Then you have to find V. V equal to what? So can you not find it? So V is equal to P by S.
दोनों का same है ना? अरे if you go and sit there, I have to go and sit there. दोनों का force and displacement का same है.
ये निकालना है. Power कितना है?
40
kilowatt is 40,000. So 40,000. F is 20,000. So it is 2 meters per second, right? So you get 2 meters per second. All gone. So see, the way to solve numericals is write down the given data and see which formula is applicable. That's it. And do match the units. Same system of units should be there. You get the answer.
Sir, I have a question. Sir, is it necessary to convert the answer into SI unit?
Yes. Unless the question asks differently. Like there was a question where you had to calculate the power in kilowatt. So it will be mentioned in the question. If it is not mentioned, it has to be SI.
And sir, also if force I have one more doubt there, one time is equal to how many newtons?
So 1 Newton is how many dynes? 1 Newton is 10 raised to 5 dynes, right? So 1 dyne will be 1 by 10 raised to 5. So you have to know these relations.
Wait, no. See, weight does not matter in this now.
Okay, which question are we doing now?
Force into second.
So we'll do now selectively, okay? Not all questions. Question 12. Hey, you did, not others. 13 करवा रहा हूँ, 12. What is 12? Boy weighs 350 Newton. Weight means F. Okay? Weight is what? mg, which is F. Understood? Weight is force. Climbs up 30 steps, each 20 centimeter high. So H will be what? 30 step into each 20 centimeter is 0.2 meter. Okay? 20 centimeter is 0.2. Should you write it like this? So if it is 20 centimeter divided by 100, then this is in meter, okay? So this is the height. So how much is the height? 6 meter. You got force, you got height. Now what you have to calculate? And it takes 1 minute. T is equal to 1 minute, which is 60 seconds. Is the data correct? Your book also has the same data?
Yes, sir.
Okay, so what you have to find out? Work done and power spent. So first, W. No, the boy is climbing up, right? So what is the height reached? And where is he lifting his weight? Force is also going up only, na? So force and so it is 1 or 0. So it is F into H. No need to mention cos theta because theta is 0 in this case. So 350 into 6. 6 5 plus 33. 6 3 is 18 plus 3 is 21. So the work is 2100 joule.
8 FM pattern.
Okay, what is power now?
Work upon
Work upon time. Which is 2100.
Everything,
Time is
gravity is
6.
same, person is same. A person of
How much is
50
this?
kg, while another person of same
6 3s are
mass
18.
must be same, gravity be same. His force be
330.
same, और his space will be same ही होगा. Because they are
36
both of
6
zero,
by
1 is to 1.
45. Okay, this is what it is. 12 done. Now we are coming to 13. Question 13 done.
So V means speed, right?
You have done 13.
So V means speed, right?
Speed or velocity?
So how speed and velocity?
If it is in the same direction, then speed and velocity same. Is your object going forward and backward? No. So you just understand, speed and velocity is same if the motion is taking place in the same direction.
So what if it is circular? So the speed will be constant and
If it is circular, speed is constant, velocity is not. Because direction is same. Here you can't say speed and velocity is same. But in one direction it is same. Okay? Now, so write down the given data. Are you following this method?
Yes.
What is given? So for person A, time is how much?
20 seconds.
20 seconds. So you put a subscript to differentiate between A and B, 20 seconds. Then what he does, his mass is another person. So mass of A is also 50 kg and mass of B is also 50 kg. What is the time he takes? He takes how much? 15 seconds. Then what do you have? Compare the work done, right? So solution. First you have to compare
Why your G should be 9.8 or 10?
work done. Is it given in the question? So G will be G. So what is WA? WA is MA G into H. How much height they are climbing up the stair? So not given. So you take it as H. Whatever is not given, use it as symbols. So how much height of the stair is same height, the other person is also climbing. So they are climbing the same height. So WB is MB GH. Okay, so therefore comparison, therefore WA upon WB is equal to MAGH divided by MBGH. Now MA is equal to MB. Okay, so everything is cancelled. 1 by WA equal to W. That is, what is the comparison? 1 is 2.
Question number 11.
MA and MB is same, so work done is same. Now, next you have to compare what? Next you have to compare is power, right? So what is PA? PA is equal to WA upon TA, and PB will be WB upon PB. So therefore, what is PA upon PB?
The power is used to work them by time. Right?
So yes, WA upon TA. I've written over here, right? So you have to divide, divided by WB upon PB. So it will be cross multiplied by reciprocal.
Okay.
Okay, but what is WA by WB? 1 by 1, right? So this will be 1 by, what is TA? 20. TB was how much? 15. By 1. WA by WB we calculated, right? So what is 15 by 20? It is 3 by 4. So 3 is to 4. So we calculated the work done comparison and we calculated power comparison. Now that's it. This was to be done. Next is
Around 11.
so all 14, 15, 16. These are good question. Okay. Can I go to 16 directly?
Sir, madam lagging.
Or let me do 15 and then rest is homework. Okay. The last question is 15. Remaining you should be able to tackle. We have done all types of questions. Next is question 15. Yeah. Question 15. Let's do the what's the given data? Man raises a box of mass 50 kg. So given M is equal to 50 kg to a height of 2 meter. So H is equal to 2 meter and T is equal to 20 seconds. Is the data same in your book?
Yes.
While another, so this is the first man. Okay. While another man raises the same box to same height in 50 seconds. So just different is T2 is equal to 50 seconds. Mass and height is same. Okay, so let it be M and H. Two men are differentiated by 1 and 2. The difference is only in the time. Same weight, the same mass is lifted by another man, and he takes 50 seconds. What you are supposed to do? And G you have to take is 10. 10 meter per second. So this is given, right? Okay. Compare the work done and the power. So solution. So in A there are two parts. Work done. Comparison. So what is work done? W1 by W2. What is W1? It is mgh divided by mgh. Same. Both are doing the same work. So it is 1 by 1. ठीक है? Work done comparison हो गया. Next is power. Compare the work done and power developed by. हाँ? कौन सा क्वेश्चन कर रहा हूँ? Okay. Second is the power comparison. P1 by P2 is W1 by P1 into divided by P2 by W2. Okay. So I've gone directly to this. The multiplier or the reciprocal of P2. So what is W1 by W2? 1 is to 1. 20. 51. So 5 by 2. This is equal to 5 is to 2. Are you getting the answer? 1 is to 1 and 5 is to 2. So power comparison is this way. So A part is over. What you have to calculate in part B? So in B, calculate the work done and power developed by. So you have to calculate W1, W2. What is W1? mgh. So how much is M? 50 into 10 into H is 200. So 1000, right? W1 is 1000 joule. Same should be W2 then. W2 is also equal to mgh. This will be 50 into 10 into 2. This is also 1000. Okay, because W1 and W2 is same. Then you have to find out power. What is P1? W1 upon T. 1. So this is 1000 divided by 20. So this is 50 watt. What is K2?
So can we name the man as man A and man B?
Yeah, I mean, if you are not comfortable with 1 and 2, you can do that. First and second is given.
Oh, so you did 1 and 2.
1 and 2, yeah. Yeah, you can do it as long as you are getting it logically right. So we got 4 answers here. Is it correct?
Yes.
So we have 1000 joule, 1000 joule, 50 watt and 20 watt. This is it. So do you have any doubts?
So can you do the last one, sir?
Should I do the last one also? Not required. Similar it is, same logic, right? Where is the doubt? Bolo. It's exactly same.
So but here gravity is not mentioned. Okay.
If it is not mentioned, then it is G. Whatever is not mentioned, take it as variables.
So if gravity is 10 Newton, right? So we can.
Array, whatever it is, 9.8 hai. So you have to take same way. If it is not, it is constant, na, in both. Okay? Yes. Yeah. So now we'll start the next chapter. If you have any doubt, just take 2 minutes to recap. We'll start the next unit, B. In this, we have already done a lot of portion in 9th standard. Okay? Right? But what is different in this unit is, so shall I proceed? It is everything written on the board. So this chapter is completed in your schools? हाँ, किसी के स्कूल में पढ़ा है?
स्टार्ट ही नहीं किया
क्या? वर्क पावर एनर्जी पढ़ा दिया पूरा?
पहला चैप्टर ही खत्म नहीं हुआ
अच्छा तुमने साउंड पहले तो वो सब करो. Yes.
Then dot force, then work energy part, machines and radioactive.
इतना सारा पढ़ा दिया? कब से पढ़ा रहे हैं तुमको?
9th semester.
अच्छा इसके लिए बहुत कुछ पढ़ा दिया तुमको. नाइन्थ में 10th का पढ़ा दिया. तो 9th का 8th में और 8th में 9th का पढ़ा है. वैकेशन में साथ साथ. अच्छा ठीक है. चलो let's start unit B, which is forms of energy, right? Different forms of energy.
वो वाला भी कर सकते
Chalo, let us see how much you know, because in some schools. So what are the different forms of energy? Tell me. How many different forms of energy are there? I have told you only 7. Only 7. Okay? So different forms of energy are 7, which are
Nuclear energy.
starting with start from the start.
Heat energy.
मैकेनिकल एनर्जी
Light. Okay. Light. Light से क्या है? Heat. Sound. These are the most basic form of energy, right? Light, heat, and sound. Then next,
Mechanical.
chemical.
मस्कुलर
Thermal is part of heat. Chemical के बाद क्या किया?
एटॉमिक एनर्जी
Mechanical.
इलेक्ट्रिकल
Electrical. Here thermal is here.
Asan
एक चीज को तुम लोग कैसे डिस्कस करते हैं
ऐसा कमाल.
So the hydro.
These are
So is it nuclear chemistry?
hydro is to do with moving water, mechanical. So it will all be grouped.
Is it nuclear a part of chemistry?
So the magnetic.
Different category.
So the magnetic.
Just studying
Electrical, magnetic, electromagnet बनता है ना, magnet कहाँ से आता है? Moving current से आता है, ठीक है? Electrical,
nuclear को छोड़ते हुए.
wind is motion, mechanical, heat, steam.
Light.
So you can group. So there are some 12 different forms given. They can be grouped or mapped into these 7 only. So remember these 7. This is very important.
Just part of the chemistry.
In this, we are going to study in detail mechanical. Okay? Out of these 7, which energy form we are going to study? Mechanical.
So the magnetic and potential.
Mechanical. That's what we are going to do. That's why I said, if your basics are clear, okay? Now what we are going to study in detail? Mechanical. So what is mechanical energy? चलो, जिसने पढ़ लिया वो मेरे को बताओ. What is mechanical energy?
So 2 minutes.
2 minutes नहीं.
There are
Energy possessed by a potential and
potential energy.
Mechanical का मतलब क्या होता है? What is mechanical?
Motion.
Motion. Mechanical means motion.
The energy.
वो motion मैंने नहीं पढ़ा.
He is a loose mouth.
Hydro motion मैंने
He is a verbal
मैंने
diagram.
वो motion
Okay.
मैंने पढ़ा.
Focus. I know you studied in school, but if I ask questions, you will not be able to answer. I can promise that. Chalo, give me a proper definition of mechanical energy.
The energy possessed by a body during a state of motion.
Due to its labor.
During a motion.
Nahi, due to its energy.
So mechanical energy is the energy possessed by a body by virtue of its state of motion or of rest or of change of shape. वो सारा कुछ आ जाएगा.
Yes, answer.
ठीक है. तो मैकेनिकल एनर्जी में बेसिकली 2 टाइप्स ऑफ एनर्जी है. लेट्स कॉल दिस एनर्जी एज ई. मैकेनिकल एनर्जी इज ई. सो इट इज डिवाइडेड इनटू 2 पार्ट्स. काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी. व्हाट इज द सिंबल ऑफ काइनेटिक एनर्जी?
K.
जस्ट के.
That's the
पोटेंशियल एनर्जी इज व्हाट इज द सिंबल?
V. Phosphorus.
यू. मैंने बोला था ना तुमने नहीं पढ़ा है.
Uranium.
Did you know this?
Yes.
Potential energy is U. Kinetic energy is K.
Potential.
Now let us define what is kinetic energy.
It is the energy
energy possessed by a body.
opposite of the body when it is in rest.
Kinetic energy.
It's a potential.
It is लिखो इसमें लिखते जाओ. It's very important. It is the energy possessed by body. This is the most important chapter of physics. All the chapters in physics are about energy. So if you understand this energy, then you'll understand light energy, heat energy, electrical energy. Entire physics is nothing but study of energy and its use. That's it. That's what you're doing, right? You're starting with what? The most basic, mechanical energy. So energy possessed by a body by virtue of its state of motion. Okay, this is the kinetic energy. So and it is expressed as
Wait, possessed is like say second time.
So any body of mass m, if it is moving with velocity v, how much energy it has?
Half mass into velocity square.
Half mv. We will derive it. Okay, this is the kinetic energy possessed by it. Next, what is potential energy? So if the body is at rest, like Andrew said, if the body is at rest, what is its kinetic energy?
Zero.
Zero, because V is zero. Yeah. Okay? So body at rest has no kinetic energy. But does it mean it has no energy?
No, sometimes it is has energy.
It has potential energy.
Yes, it may have. So it will depend. So what is potential energy? It is the energy possessed
Body will also velocity can have more kinetic energy.
by a body.
A body moving at a
No.
By
See.
if it's moving above light speed at a constant
okay, don't try to be intelligent when a teacher is teaching. Listen attentively. So why are you paying attention?
I wasn't thinking of my pen.
So when I'm teaching you, listen, right? All your questions will be solved. All your doubts will be cleared. Just listen. You can have a discussion, conversation later, but not when I'm teaching. Okay? It is the energy possessed by a body by virtue of its
State of rest.
its change in position, change of position, or change of configuration. Change of configuration. You have been taught this, right?
Yes.
So what does it mean? Who will explain? What? What does it mean? It is the energy possessed by a body by virtue of its change of position.
Possessed should be POSSE, SSED, right? Yeah, there is only one.
Whatever, yeah, just see the dictionary.
Okay, so I'll get
He is focusing on wrong areas actually.
No.
Yes, exactly.
Means like spelling, even I
Stop
don't really.
talking too much here. You just unnecessary a big mouth. Don't be that. Loose mouth, not big mouth. Big mouth, you've got to be a big person for it. So don't be a loose mouth. Focus.
So 1 second. Sir.
So we will now weigh every word and try to understand it. So many big mouths around. Okay. Shall I explain?
Yes.
Would you like to try? For those, it is covered in 9th standard, or it's already gone.
So क्या explain करना है?
What is potential energy?
It is
Kinetic तो समझ में आ गया.
it is the energy possessed by the body in the state of rest.
Okay. Before that, what is energy? What is energy? We are discussing energy, right?
Energy.
What is energy? Chalo, who will raise your hand? What is energy? What energy lets us do?
capacity to do work.
Yes. So that's what. Okay. Energy is capacity to do work or ability to do work. So when he said capacity, was he wrong? No. You will have ability only when you have capacity. So one follows the other. Okay, just the play of words. Okay. So now, what is potential energy? What is potential energy? Dekho.
Energy.
It is the energy possessed by body due to its shape or size. Virtue of which
It
is the energy.
Look here. Is this duster visible?
Yes.
Does it have any? Does it have any energy?
Yes.
Yes. A lot of potential.
No. Wait. Is he able to do any work?
No,
No.
because the potential energy helps to change.
Hidden talents.
Can this duster in its this
No.
position do any work?
No, because it has no life.
तेरी बातें नष्ट की बातें.
Now listen. I am lifting it up. What did I do on the duster?
Kinetic energy.
What did I do on the duster?
Move it up.
I moved it up. So what did I do? I worked on it. I had told you whenever you work on a body, what happens to its energy?
Increases.
Increases. Because work and energy same thing.
Yes.
W equal to E, right?
Yes.
So when you work on any body, what you are doing is you are increasing its energy. So now it has some energy. Now it can do some work.
Every time I do work on a body, I increase capacity.
Yes.
To do work.
Yes, which is you are increasing its energy.
So every time someone does work on me, it's increasing my capacity to do work on that.
Exactly. When you eat food, food works on your body. When you eat food,
It does.
okay? Or maybe if you overeat, then it will start working the other way. Okay. So basically, okay, pay attention here. If you understand this, all the numericals will be able to solve effortlessly.
So he's working hard and breaking my knee.
I'll send you both out of the class. No, I am telling you. Now you get this English very well. You'll be out of the class. Next time you will discuss. Okay? Whoever is the responsible person, I don't care. Okay? Duster is lifted up, its energy is increased. So what this duster can do? It can do one. Now imagine there is a nail. Let's say it is a hammer. Okay? And there is a nail here. Now if I drop it, will the nail pierce into wood? It will. Yes. You hammer a nail.
Depends on the nail the wood.
Yeah. So it will work. Imagine it has energy to basically press the nail into wood. So it has displaced nail into the wood. So it did work. So this kind of energy, which is acquired due to change of position, energy possessed by a body by virtue of its change of position. Let's say ground was position A, you lifted it to another position by working on it. Now it has energy. Which energy it has? Potential energy. More specifically, it has gravitational potential energy. You just be quiet here. You're just too irritating it.
Potential moving, you're having kinetic energy.
You understand the difference between asking a question and being irritated.
Yes.
I have not completed your asking question.
We'll start with this.
Stand up. Come on. Just be smart, not over smart. Stand here. Go. When you will ask question when I have completed.
You did ask a question.
You will ask me question when I have completed. You understand? Not while I am still not finished. You are not improving. Giving you so many chances. Stand quiet. So is it clear now? The energy possessed by body by virtue of its change of position is potential energy. Next will be you. Okay? So this is potential energy. And what kind of potential energy? Gravitational potential energy. Why? Because you are working against the gravity. Is it clear? So it is potential energy, but what type? Gravitational potential energy. So in potential energy also you have two types. Gravitational potential energy. Okay? And it is due to change of position. Now next, what is the other type of potential energy? Change of configuration. What is change of configuration?
The shape.
Change of shape. Like in case of, give me an example of change of shape in case of spring. Okay. So let us say you have a spring which is relaxed. Listen. What spring is this? Relaxed spring. Yes, relaxed spring. Now you have kept a ball on it. Now relaxed spring has no energy, right? With the ball, because it is a equilibrium state. Okay. Now when you compress it, press it. Okay. So what will happen? It will get compressed. So what did you do while compressing the spring? You worked on it. Okay. What did you do? You worked on it. So you pressed it in which direction? Downward direction. So you applied force on it. You applied force on it, right? So now it has energy. Okay. So now when you release, when you remove, like when you release what is it doing? It is doing the work. If it hits the nail, nail will pierce. So this potential energy, now when it is moving, it had kinetic energy. So see what is happening. Energy is not coming from anywhere. It is getting transferred. When I did work, I lost energy. My energy lost is now stored in this duster. That duster's energy now works on the nail. So that nail moves in. Then once the nail moves in, it produces heat. So that is gone back to atmosphere. Hold it. So what is happening? Only energy is getting transferred from one agency to other. It is not created or nor destroyed. Is it clear? Sit down quietly. Law of conservation. Sit down quietly. So this is law of conservation of energy. Now tell me, what was your question?
So how your energy is stored into that duster? How it goes?
It is stored when you are holding it.
Okay.
When you release, then that energy change from potential now to kinetic.
Okay.
Here also it is stored when you are holding it. Somebody is holding it. All the potential energy comes whenever you work against some existing force, like when you are working against gravitational force, where you are working against spring force. When you are pressing the spring, what is the equilibrium state, relaxed state? It will try to go and reach its relaxed state. So potential energy only comes when you are working against some existing force, like gravity, spring force. Yes.
Sir, so if I will talk about duster itself. So right
It was a
now,
good question, by the way. How the potential energy is stored when you work against some other force.
so right now the duster is at rest, but still it is on work because gravity is acting. Right?
Yes. So if this table is suddenly pulled, then this duster will have. So potential energy is a very relative concept. So if you assume that right now at this level, potential energy is zero, then with respect to this level, now it has potential energy. It's a relative concept. So where potential energy is going to be zero? On the surface of Earth.
On the
But again, with respect to center of Earth, it has some potential energy. So it's like relative concept. Yes.
So if the body is sitting on a table and there is no change in position or shape,
Hmm.
you have zero potential.
Yes. Because assuming this is the last level. Okay, then only.
With respect to the surface.
With respect to this surface, it has zero because there is no height. Okay.
But if
Is
the
it
body is
clear?
at the center of gravity, would it have potential?
Sorry.
So like if you have it on the center of Earth, like then you have all the gravity concentrated on that point. So will it have potential?
No, because there is no relative height.
So what energy?
It has no energy, nothing. At center. You need level, the difference of height. Okay. So now, first let me explain the other type of potential energy, which is elastic potential energy. What is elastic potential energy? Whenever you undergo change of shape, then it will have which kind of potential energy? Elastic potential energy. Wait, I am not yet done. Now, suppose you release the spring. So then what will happen? This spring will regain its relaxed state. So it will suddenly, and it assumes that relaxed state suddenly. So it will throw the ball up. So whatever was elastic potential energy of the spring is now converted as kinetic energy of ball. This is the principle on which revolver works. So when you load the gun, you pull the trigger.
Yes.
So trigger has got a spring attached to it. So now it has potential energy. Now when you release the trigger, it hits the bullet, and the bullet speeds up. Yeah, so pen is like not a correct example, but revolver is a correct example. Even in pen, the moment you press it again, then it releases. So pen goes up. It is in short span, yes. Got it? So you understood what are the two different types of potential energy? Gravitational and elastic. Elastic is due to change of shape or configuration.
Suppose how is that a change of shape because it is
It has change of dimension, right? What is shape? Dimension. Is its length reducing?
change of shape.
Change of shape could be due to anything, right? So, like other is, let's say if you have a bow and arrow, right? So if you have a, so how do you have a bow? Let us say this is the relaxed state of the cord or string of the bow, and you have an arrow like this. Okay. Now it is pulled back. Let's say it is pulled back. So arrow comes here.
It's reloaded.
So when you pull back the string of the bow, where is the elastic potential energy stored? In the string. This will now have elastic potential energy. Has its shape changed?
Yes. Yes.
Shape has changed, right? Dimension has changed. So now it is elastic potential energy. What is elastic body? Whenever you remove the external force, it tries to regain its original shape. So it will regain its original shape. So in the process, what it will do? It will transfer the potential energy into
The arrow.
kinetic energy of arrow. Now, another form of potential energy. When you have electric cell,
Yes.
does it have potential energy?
Yes.
Yes, it is a stored energy. Any stored form of energy is a potential energy. So what kind of potential energy is there in the battery terminal? Electric potential energy. It is no more gravitational potential energy. It is electric potential energy. Why? Because now you have two opposite polarity charges on the terminal. So whenever and who is maintaining that charge difference? The electrolyte and electrode reaction. When you have the electrode inside, the electrolyte basically reacts with it, makes one of the terminal positive and another terminal equally negative. Why it takes place? The chemical energy is converted into electrical energy. Why electrical energy? Because now charges are opposite, so they have the capability to attract each other. So if you put any free charge, it will attract. If it is negative, it will attract to positive terminal. Okay? So the moment, so why these are able to maintain the charge difference? Due to chemical reaction. Now you put a conducting path, like you attach a small bulb to the battery, then the bulb will begin to glow. Why? Because now charges are flowing. The electron begins to flow from negative terminal to positive terminal. So electron flows from low potential to high potential. You studied it in 9th standard. Okay? And the current flows in the opposite direction, the conventional current, high to low. These are the convention, right? Current flows from high potential to low potential. So that is also example of potential energy. But right now we are learning what type of potential energy? Gravitational. But that's not the only potential. It can be in different forms.
So someone has to pull the bow so the energy.
You spend your energy. That energy got transferred into elastic potential energy.
Okay, then
When
it
you
will.
release,
Metal string have more elasticity than the rubber string, so like there would be more potential energy in the metal string.
yes, exactly. Like you have a guitar string, right?
Yes.
So when you pluck the guitar, which is pressed tight at both the ends, it will have, but then it will be vibrational type of kinetic energy. No, that's motion. It will also have potential energy. Elastomers are like with little force, it will change drastically. The shape will change drastically, like the hard tissue brush. So that they are.
Pacemaker.
Rubber band is also elastomer. With little effort, you can change the shape too much. But you know what is more elastic? Is steel or rubber?
Steel.
Very
Or
neat.
elasticity is defined as the ability of an object to come back its to its original position after its.
Exactly. So rubber, if you stretch it after a point, it will break off. Right? It's to do with the deforming force and modulus of elasticity. You'll study that in 11th standard. You need more, mathematical concepts to define that. So right now, you just restrict yourself to change of shape, qualitative aspects. So is it understood? So likewise, if a stretched rubber band, that will also have elastic potential. Okay? Now let us find out expression of gravitational potential energy. So elastic potential is only qualitative discussion. That's it. You have to work more on gravitational potential. So let's learn about expression of gravitational potential energy. So how will you find this out? So let us say you have any object whose mass is, let's say the duster example, it has mass m. Now you lifted it to certain height h. Took it here. How much force you have to apply in upward direction? At least weight of the duster, right? Which is mg. So how much potential energy it will have? Therefore, U is equal to how much? If the work done in lifting
mg into h.
in lifting the object.
mg into h, right?
Yes, so it is mg into h.
Or force into h.
So this work done is stored as potential energy.
Potential energy is equal to mg.
Yes. Gravitational potential energy is equal to mg. Okay? So, and I have also told you that in the same situation, gravity is doing negative work. So, who is doing positive work? The agency, the one who is lifting against the gravity. Okay?
So that's negative, right? If you are doing against the gravity.
But I am applying force upward
Yeah.
and body is also moving upward.
But
So,
gravity.
I am doing positive work. Again, forget it. I am doing positive work. So, my work done is positive. Gravity's work done in the same scenario is negative.
Yeah, so if you will go up, so so gravity will work on our hand also, right?
But
So
which work am I asking you? Work done by me, not by gravity.
oh, achha, for you it's positive.
Yes. Now you get it.
But for gravity it would be negative, right?
Negative, because gravity force is, weight is downward, but displacement is up.
Picking up.
Theta is 180.
Okay.
So is it clear? Expression of gravitational potential energy. Now we'll derive the expression of kinetic energy. This was cleared in school?
No.
Yes, sir.
We didn't do it.
No, those who did in school, did they discuss all this?
Yes, sir.
They must have.
If it's in physics chapter, we are started with simple questions.
You started with simple, but all this treatment didn't register.
Yes.
Huh? No, you have a self-doubt.
Somewhat.
Somewhat. But now I think it is clear. Any doubts now you can ask. Now the open forum. Chalo, anybody has any doubt now ask. Now I have explained everything. Huh? Is that a doubt? Go. I said if you have any doubt ask. Any doubt now? Now on potential energy. What is elastic potential energy?
Even I got one doubt. What's the means elastic potential energy and gravitational potential energy? What's the difference between?
Exactly. Gravitational potential energy is due to change of position. And elastic potential energy is due to change of configuration, change of shape. यही तो difference है. So any body
Change the shape of the host body.
So
on which you are working,
so
change of shape.
I have one more question.
In
See,
both cases, there is a body involved. In one case, the position of the body is changing. In the other case, its shape is changing.
so question.
Yes.
So like if I will take the duster, I will throw it upwards, so it will come down.
So if I throw this pen on your head, will it hurt?
Yeah.
So whatever energy I transferred in the pen appeared as its kinetic energy. That worked on your head.
Yeah.
Tried to displace your head, but you are a rigid body. It is trying to displace. So if it hits, let's watch it in slow motion. It's not hurting. When I'm moving with the pen, I'm so flexible.
Yeah.
But you are not flexible. That.
Yeah. So
That work is appearing as a hurt.
So, like for example, if I will take a string and if I will glue the ball with the top of the string. So if I will stretch it, stretch the string. No, I mean the spring, and it will come on its original position. So the
So
position
if the
of
ball is glued, okay.
yeah.
So when it goes up, the ball will try to pull the string further. So maybe the string will go along with the ball.
Yeah.
Till it can, but then there will be a point when string.
Yeah. So the
it will pull
position
it
of
back.
the ball changes, right? So that's not elastic.
It is elastic only, na?
So how the position
Elastic in the spring, but ball will have kinetic because ball has motion. Assuming ball is rigid, its shape is not changing. Ball is rigid.
Yeah.
Shape changes only of the spring. Okay, again cross down. Shape changes only of the spring, not of the ball. So if the ball shape is not changing, only motion will have kinetic energy.
Yeah, only motion.
Only motion. So change of position. It will have only.
So that's neither
Gravitational
elastic nor gravity.
So it's a hypothetical case. Now you understood the basic concept,
Yeah.
right? Now think through. Okay. So different scenarios will have different outcomes. Okay. Can we proceed now?
Yes.
Okay. Next is we derive the expression half mv square. Now how do we derive it?
Half mass into constant.
How do we derive it? What logic?
Half mass into
Derivation of
half of this.
expression of kinetic energy. So what logic should we follow? See, imagine you have a body, right, which is moving. So moving body has a kinetic energy. So whatever work you do in stopping that body, let's say a moving body is coming towards me and I try to stop it. So I will also be moving back with it for some time, but ultimately I'll stop it. So whatever work I did in stopping the body, that was its kinetic energy.
Who's kinetic?
Isn't it? The moving bodies. Okay. So let us say this body is moving with velocity v in this direction. Its mass is m. So to stop it, I applied force in this direction.
Yes.
But it still continued to move till this displacement before it finally ultimately stopped.
So it means the box
It's
is
like,
the-
let us say you're standing here and your friend came running in front of you. Okay, you're standing. So you're trying to stop him. So what will you do? You will also run back with him for some distance. And then you are holding him there. So you're able to overcome his energy. Okay? Clear? So therefore kinetic energy K is equal to work done
What happened?
work done in
Please,
stopping
Basic.
a moving body.
So we are going to watch.
Work done in stopping a moving body. All of you got this logic?
Meena Petra, no?
Yeah,
I was using that.
yeah.
Okay, so now work done in stopping a moving body. So what is work done? F into S. What is it? Work done is F into S. Now what is the direction between F and S? Is this a retarding force or accelerating force? Retarding force, right? So it will be cos 180. This force is in the opposite direction. So it is causing what? Retardation. Okay, it is causing acceleration in this direction. Got it? Because displacement is left to right, force is right to left. So what is cos 180?
Minus FS.
Minus Fs. And what is F? M into
G.
minus A. G. This is horizontal. Into S into minus 1. So what you're getting is minus minus is M A S. This is what you got. This time it is girl's turn to get the punishment. Okay, you are not isolated from punishment. Don't be so casual.
Force velocity image. Force velocity equal to MA.
Why is it not? Did you not study second law of Newton? Huh?
It should be minus MS.
So M into what is minus retardation? No. Let me explain. Na, he's asking. What is the force direction opposite to the motion? So it is retarding. So retarding means force is negative because of negative acceleration. When the acceleration acts opposite to the direction of motion, it is negative. Have you studied that? Yes. So then A is negative. So we get this expression. Correct?
Minus 8 to 1 is.
Minus and minus. Okay. But what is this displacement? Now imagine what was the initial velocity? Initial velocity was this. And what is the final velocity? Here the body is stopped. So final velocity here is 0. What is initial velocity? In this case, U is V because it was moving with some velocity. And that V finally is 0 when the body is at rest or stopped. Okay? Body is stopped. Okay? So what is displacement then? What is using Newton's third equation? So this is the expression for K so far.
Every reaction
But
has an
Every
opposite.
action has
Third equation of motion. But by third equation of motion, not third law, third equation of motion.
Oh, these equation was derived by Newton.
What is third equation of motion? E square is equal to U square plus 2AS. Right? So what is V? 0. What was U? It was moving with V. What is A? Minus A. Then S. So what do we get? Simplify, rearrange.
B square minus 2.
So it will be minus V square divided by
equals to 2.
S is equal to minus V square divided by minus 2.
Yeah.
Which is V square by 2. This is 2. So in book, these steps are confusing, so you better note it down.
Yes. So derivation would be asked in exam, right?
Yes, it may be. Okay? So what did you get as V square by 2A? So therefore K, so from 1 and 2, therefore from 2 in 1. Substitute 2 in 1. Therefore, what is it? You have K is equal to MKSS. What do you have? Is it correct?
Yes.
This is it again. So in the textbook, they have not considered signs. So while reading, you might get confused. Here it is all. Where is the force? In the opposite direction of the moving body. So it is retarding force. The retarding force means retarding acceleration. The body's speed is increasing or decreasing. A moving body is coming to rest. So what is its acceleration? It is undergoing deceleration. क्या हो गया? Camera is moving.
Oscillator equation.
Is the kinetic expression understood? Camera? Andrew, have you understood this?
Yes, sir.
So this is what you should understand. Okay. Now there are, just like potential energy, we have different types of kinetic energy. Just like two different types of potential energy. What was the two different types of potential energy?
Gravitational
and
energy and
elastic. Likewise, we have different types of
kinetic
kinetic energy. Not kinetic energy is because of the motion. Are you still writing it? Done writing?
Yes.
Everybody done writing? So I'll explain. Okay. So what are the different types of motion you're familiar with? Raise your hand.
Types of kinetic,
Linear motion is one.
rotational motion.
So linear
translational motion.
Linear or translation, same thing.
Rotational
Pirated.
Yes. Second is
Rotational.
rotational.
Vibration.
Yes.
What do you do?
And vibration.
Why do you do that? What do you do?
So these are the three types of kinetic energy because we have three types of motion. Now give me an example of each one of this. Where can you find linear?
Linear.
So car.
Car. Any car moving or any body which is moving in a
Another example is
straight line.
line.
Car moving in a
Sir, rotational I can tell.
Fan. So another
Yes.
example of
Sir, vibrational
rotational is
fan.
electric
Vibrational mobile phone.
Vibrate.
Mobile phone.
Strings of a guitar.
fan. One at a time. Okay.
Vibrational.
Strings of a guitar.
Strings of a guitar. Correct. So string of a guitar. Anything which is vibrating. Anything else by string of guitar. Rotational का example बताओ. Fan.
Wheel of a car.
Wheel of a car. Very good.
So linear motion, for example, ball,
Ferris wheel.
a ball
Now
rolling.
wheel of a question. Wheel of a car. Does it have only rotational motion?
No.
It
It
has
has
linear.
linear
It
also.
has wheel also. So it has both. Wheel of a car has translational as well as rotational. So it can appear as a combination of these. Okay? So these are three different types of kinetic energy by virtue of different types of motion. So you may be asked to answer a question to give example of different types of kinetic energy. This is it. So any questions still here? Okay. Yes. Yeah.
Nice question.
Next is
Sir, can we say vocal cord as a vibrational motion?
yes. Because it is vibrating, right?
Like
Any clock pendulum,
Body.
any clock pendulum has a vibrational energy.
Headshot.
what's the idea? अरे वो हार्श कुछ नहीं है वो तेरा ही सुन लिया
चलो ये हो गया.
और नहीं किया
Next is relationship between kinetic energy and momentum. K and P. What is P? Momentum. Momentum. So where K is kinetic energy.
Could you please revise what movement?
K is momentum. Momentum is product of mass and velocity. What is momentum?
Maybe a small
Small p. Capital P is pressure. Okay, or unit of power. So what is the relation? Since K is equal to 1 by 2 mv square. Okay? We can multiply divide by m into mv square. Just multiply and divide by m. So what you will get? So you get mv whole square by 2m.
half into P into B.
This is the relation. Multiply and divide by m.
P, no? P equals to P.
I have done this. Multiply and divide by m. To get a perfect square mv, so we get momentum square, right? Or in terms of momentum, what can you do? You can write 2mk is equal to p square. This gives p is equal to square root of 2m. So any relation you can use, p to k or k to p.
So,
Okay.
so we need to use this formula for the computation.
Yes, this and this is same, just rearrange. One in terms of p.
But if momentum is Fp and we substitute the value of momentum which is Fp into that equation, we'll have P by 2 into V.
So just that you will get
How will you get P by 2 into V?
If FB is
If you take V out, yeah, you can do it. Depends on the
because
question.
it's half into F into B into B.
V into V, so PV, it is P into V by 2. That is also possible. Okay? But this is the most standard expression. Okay? Next is work energy theorem.
Why are you folding?
Have you written it down?
Yeah.
Yes, sir.
So the next is work energy theorem. Anybody remembers?
Yes, work is equal to energy.
Work is equal to what? Gain in kinetic energy. So what is work energy theorem? It is called V theorem, work energy theorem. Okay, WE theorem. So which is W is equal to K final minus K initial.
So you want to focus on the kinetic. Then work is equal to kinetic.
Gain in kinetic energy. Okay? So this is the theorem. Work done is equal to final kinetic energy minus initial kinetic energy. So what does it mean? I'll explain. Suppose you have a body, okay? Now this time it is moving with some initial velocity u in this direction. And now a force is applied on it. Now where the force is applied? In the direction of motion. So now it will get an increased speed. So now it is accelerating. So now in this case A will be positive. And now let us say it reaches after some displacement. Energy is gained. You are working on the body. Okay? You are working on the body. So energy is increasing, right? So now its velocity is, final velocity is V at this position, let us. Work acted till over this displacement. Okay? So here it will have more energy than it had previously. So therefore, what is the energy? Work done by applying force over displacement this. I am working on the body. So what is the work done on the body? Is equal to F into S. Now what is F? M into A. And how much is S? S is V square minus U square upon 2A. Isn't it? By third equation of motion. We just did this previously.
Yes.
So just in this case it gets cancelled. Then what do we get?
Plus acceleration. No.
Mass multiplied. So half mv square minus half m u square. This is what we get. Yeah. What is it? Half m. You just split the denominator. You just multiply it.
Half would be
But what is this
cancelled.
now? This is the final kinetic energy.
Yeah.
And this is the initial kinetic energy.
It should be V square minus 2. So it should be V square minus 2, right?
What is it?
No, I mean like half m and half m would be cancelled, right?
What is this? Which school have you learned mathematics?
I'm wrong.
God save you. Chalo. So this is work energy theorem. After the break.
हो गया खत्म हो गया तेरा टाइम
नहीं भी करना
होगा ना।
नहीं है ना स्कूल छुट्टी है नीचे के देखो स्कूल
यार मेरा बैग कहाँ पे है?
अरे मैं कहाँ बैठ
क्या कर रहे हैं? अरे यार तेरी आ गया।
देखोगे
भाई भाई सॉरी इतना ब्लैंक क्यों लग रहा है?
वो मुझे मेरे पास खाने को है
मुझे अजीब है क्या?
Oh, wow.